Welcome to the Explainer. I want you to picture this. You walk into the expansive, sleek lobby of a modern skyscraper. You stroll up to a set of metal doors, step inside a small, brightly lit box, the doors glide shut, and suddenly you're smoothly soaring dozens, maybe even hundreds of feet into the air. We literally do this every single day. We completely trust the system without even a second thought. But today, we're going to look past those closed elevator doors to see what actually makes this daily vertical journey possible. We are breaking down the hidden mechanics, the digital brains, and the rigorous safety systems that truly power our modern cities. But seriously, have you ever stopped to wonder what's going on just inches away from you, right behind those closed doors? We push a glowing button and magic just seems to happen, taking us precisely to our destination. But it's not magic at all. It's an absolutely incredible feat of hidden engineering. We're talking about a complex ballet of steel, electricity, and code operating in a dark shaft right beside us. Every single day, elevators safely carry billions of passengers, which statistically makes them the safest vehicle in the entire world. As passengers, we usually only get to see the finished product, but today we're exploring the magnificent machinery at work behind the scenes. So here is our roadmap for today's Explainer. First, we'll take a look inside the modern elevator. Second, we'll explore powering the vertical journey. Third, we'll uncover the brains of the operation. Fourth, we'll look at the bulletproof safety systems. And finally, we'll wrap things up by comparing traction versus hydraulic systems. All right, Section 1, inside the modern elevator. Let's just literally peel back the layers of the building like an onion and take a cutaway view of the entire hidden elevator system within the shaft. Now, to really understand this system, we need to define the heavy lifter right away. Meet the traction machine. As the definition points out, this is the primary lifting mechanism. It consists of two main parts, a super powerful electric motor and a drive sheave, which is essentially just a heavy-duty pulley. This unit is typically tucked out of sight in a dedicated machine room at the very top of the building. Establishing this vocabulary right off the bat is going to make the rest of this explainer so much easier to grasp, because this machine right here, it is the true muscle of the operation. So what does the actual physical framework we interact with look like? Well, first you have the elevator car itself. That's the cabin where we stand. But if you look above it, you'll see it suspended by incredibly sturdy steel cables known as hoist ropes. And notice the sides. As the car travels up and down, it isn't just swinging freely in the wind. It travels securely along rigid, perfectly straight guide rails that run the entire vertical length of the shaft. And capping the whole shebang off at the pinnacle of the building is our machine room. Okay, let's dive into Section 2, powering the vertical journey. So the absolutely crucial point here is how these components actively work together. Up in that machine room, the electric motor fires up. It rotates the drive sheave. Now, those hoist ropes, the thick steel cables attached to your elevator car, they are looped tightly right over the sheave. Thanks to the immense friction or traction between the steel cables and the grooves of the sheave, when the motor turns the sheave, it physically pulls the cables. Rotation in one direction raises the car, and rotation in the opposite direction lowers it. It's just a direct, beautifully simple mechanical action. But this builds into a really ingeniously efficient system, thanks to the counterweight. It's basically a massive block of stacked weights hanging on the opposite end of those hoist ropes. It acts to balance the dead weight of the elevator car, plus about half of its maximum passenger capacity. Think of it exactly like two kids on a seesaw. Because the counterweight is pulling down on one side of the sheave, the electric motor doesn't have to lift the entire heavy car all by itself. It only has to lift the difference in weight. It's an incredibly elegant solution that dramatically reduces the energy the motor needs to exert, which makes elevators surprisingly energy